Today on Home Built Workshop, we're going to take a look at something that I'm hoping will complete the trifecta of digital manufacturing. We're going to check out this xTool D1 Pro 20-watt diode laser. Is it going to work for our needs? Let's set it up and find out. What's going on, everyone? Welcome to this episode of Home Built Workshop. I hope you're doing amazing. Yes, I'm hoping to complete the digital manufacturing trifecta. I made that up. I don't know if that's official or not. What the heck is that? There are three machines that I consider kind of that trifecta in the computer digital manufacturing, and that's the 3D printer, the CNC machine, and the laser cutter. We've got the first two covered. We don't have a laser cutter covered just yet. What we're going to check out today is the xTool D1 Pro 20-watt diode laser. Before we pop this thing open and get it set up and try it out, I need to say thank you to the team over at xTool for sending me this unit to test out here in my shop. As we move through this test, if you decide that maybe you might want to try out one of these machines, I'm going to put some links in the video description. That's enough yapping. Let's set this thing up. Inside the box, everything looks nicely packaged. Here we have, looks like our assembly manuals. We have some sample material here. That'll be kind of fun to play around with. And here's all of our bits and pieces. Nice red anodized aluminum. I think that's aluminum. A magnet doesn't stick to it, so pretty sure it's aluminum. Whatever it's made out of, it's non-magnetic, but regardless, this is a really cool color red. Of course, red's my favorite anyway. Now I'll just remove the rest of the pieces from the packaging. Everything has a little foam cutout and is packaged really nice. Here's our laser module. And as weird as it sounds, I am going to take a couple of minutes to read the instruction manual. First it says we need to cut this zip tie. Now I'm going to go ahead and lay out the pieces the way that they need to be assembled. Inside this box of parts, oh, look at that, zip ties. Kind of cool, a little tool kit there. Even comes with an Allen head and a screwdriver. All of the tools that you'll need to assemble this machine are included in the little toolkit. Now we're going to just line these pieces up and start securing them together. These are all countersunk holes for the screws. Should be pretty easy to get things lined up and started. The right hand piece has little cutouts here for the power switch, the power input, and the USB plug. So you need to make sure that side goes toward this control board where your switch is. Well, nope, I found it. We're good. Now that I have one screw in the top of each corner, that's holding the frame together. Now I need to go around and install 3 more screws that go in from the side. There's 2 on the bottom and 1 on the top. And these take the same screw that goes in the top. It's kind of nice that they're the same. You don't have to worry about which screw goes where necessarily. And I'm not tightening these screws down just yet either. I'm leaving them a little bit loose. Once I have all of the screws lightly screwed into place, then I'll go around and snug them all down. Next, we need to install the screws that are going to allow us to set the tension on these belts. You can see here that this belt tensioner is loose. There's also one on the opposite side as well. There's a hole in the back that screw passes through, and that threads right into the back of that tensioner. Now we're not going to tighten that up yet because we'll need to adjust this tension later, but we want to get the screw in there, at least for now. Next up comes this drive shaft, I guess we'll call it. This has a split coupler which needs to slide onto the shaft first. Then we need to take the end of the belt and loop it around the gear on the end of the drive shaft. I had to get in there with a pick so I could get a hold of the belt because my fingers weren't cooperating. Once the belt is looped around the gear, there's a bearing underneath the control board that the end of the drive shaft slides into. It was a little hard to get the camera at the exact angle, but here it is in place. And now we'll use the end with the split coupler to connect the drive shaft to the shaft coming off of the stepper motor. Try to keep the connector centered between those two shafts and snug them down with the included Allen wrench. Next, the instructions say to slide these gold sliders to the front of the machine, but I found a little bit of a problem here. I guess by sliding these to the front edge, they're supposed to be aligned at the same point so that everything stays nice and square. Well, that sounds great, but on one side, the side where the power button is, there's a little piece of the control board that sticks out that causes this bracket not to go all the way to the red rail. The opposite side does go all the way to the rail, but I think if I tighten them up as they are, they're not going to be exactly parallel with each other. To get around this, I think I'm just going to slide these brackets to the opposite end of the machine where they both contact in exactly the same spot, and I'm going to use that to align my parts. Now, using the Allen screw in the end of the belt tensioner, I'm going to put a little bit of tension on these belts since everything's now in place. Now we can begin making some of the electrical connections. Before you plug in any of the wiring, take a minute and make sure that the connections you're about to plug a wire into match the connector. There are several different connectors that are used. Some have different numbers of pins or maybe pins in different locations. You want to make sure that it matches the plug that you're about to plug into the cable. This first connection is the one between the stepper motor and the control board. Now we're going to move on to what I believe would be called the X-rail. Again, we need to cut the white zip ties only to loosen up all the wiring. There's one plug by the stepper motor that we need to plug in. And now it's just a matter of aligning the rail with the bolt holes on the brackets and installing the screws. As I'm editing this video and watching the process, I'm actually wondering if sliding the sliders to one end or the other is actually necessary. Since this X-rail gets screwed into each of those gold brackets, I think in theory that should square everything up. So I'm not really certain as to why they say to slide those brackets to the one side. Now to connect some more wires. Here I have the machine flipped upside down because it's a little easier to see what I need to do. The first one is this little jumper which connects to the X-rail we just installed to a little control board that connects to a limit switch on the Y rail. And now I'll flip the machine around so that I can see a little bit better, and we're going to connect the cabling from the X-rail to the main control board. This step I found is pretty straightforward because all of the connectors are color-coded. There's a white connector, a yellow connector, and a red connector. Those all just get plugged in to the corresponding color that matches the jack. Next, we need to do a little bit of cable management using the included zip ties. Now, I have heard in the past that the cable management is a little wonky on these machines, so we're about to find out how that's going to work. I'm trying to tie everything up out of the way so that it stays under the machine and there's no chance of it being caught by any of the mechanisms. I've seen where some people have had to do some different things to keep the cables out of the way, and I may end up doing that as well, but for now, I'm just trying to tie them up out of the way as best I can. One thing that I do think is pretty cool is that xTool has included holes already in the frame that are meant to use to tie these cables to. I just think that's kind of neat that they thought ahead to try to include that. Now we'll just flip this thing back over and we can mount the laser head. Laser beams. This thing has a little clip built right into the top. You just put the wire in there, then we can connect our connector. Connect our connector? Now in order to be able to slide the laser on, there's this little locking screw here. I don't know if you can see that little tab that sticks through that allows you to slide the laser down on and then lock it up with this little thumb wheel. But right now it's screwed in so that it's sticking out into this little dovetail slot. So we need to back that off. But you can't just back it off because it runs into this rail here. So you have to pull the thing out. It's kind of just indexed. See, that's far enough? There we go. Oh, apparently I missed a step in the instructions. Before I slide this on, I need to install this little airline fitting for the air assist. Now I am going to be connecting the air assist here. This just threads right into the side of the laser. There is a little piece of plastic or something covering this hole, so we got to get that off there first. There we go. What is that? 6 millimeter? 8 millimeter? 8 millimeter, look at that. And for now it comes with this little cap. I'm going to install that just to keep any dirt out of there till we're ready to connect everything for the air assist. There, now we can slide that on. Now we need to install the SD card, which it comes with. So the SD slot goes in with the terminals facing down. Now we need to set the tension of our timing belts. As I'm checking them, really, they feel about the same. This one over here may be just a little bit looser. So I'm going to tighten this screw that we put in that threads into the tensioner. I think we're good on those belts. You don't want to get them too tight or you could stretch out or break the belts. But I don't want them to slip either. I think that's all right. I want to double check before firing this up that the cables are going to stay out of the way, so I'll just move the machine through its range of motion and just see if I can see any sort of issues that might arise. I can see where the cables along the underside of the frame could possibly get in the way, but for now, I think they're okay, and I'm going to try it. So I think that completes the assembly for the laser. Let's see what we need to do to connect the air assist. All right, so if I understand this correctly, this thing is really just kind of an air pump. So really this is really quite simple. Comes with this tube, of course that connects there. This connects to the fitting on the laser head, and really that's all there is to do. The nozzle we have on the machine already has the fittings that it looks like we're going to need. So I'm not quite sure what that's for. Maybe they're spares, maybe it's part of a different kit. I don't really know. We'll set those aside. This little air pump, it moves a fair bit of air. It's going to be plenty of air to clear away smoke and things. The advantage, let me shut this off. The advantage of using an air assist, whether it's this system or maybe you fabricate some sort of a system, or your machine, maybe you have a different machine and it has its own air assist. The air assist helps blow the smoke and fumes away from your material. When you're cutting or engraving wood especially, you can get like some smoke staining on the product, and there's some different tricks and techniques that you can do to help eliminate or at least reduce that. But having an air assist is a big part at helping to reduce that smoke staining and kind of those burn marks. It just blows that smoke and things away from the piece. So I think the amount of air that comes out of this is gonna help. It feels about like other lasers that I've used, maybe even a little bit more. We'll see how that works out. Well, I believe for now, that wraps up the assembly. We're ready to fire up some laser beams. Before I do that, I need to get this thing set up. I need to get the software installed. This machine, at least for the setup, needs to be connected to a computer so that you can get all of the settings and stuff done. And then from there, it can run off a Wi-Fi. So I don't have a computer out here. I'm gonna have to take this thing inside, find somewhere to set it temporarily so that we can get it set up. After downloading the xTool Creative Space software from the xTool website, I plugged in the laser with the USB cable and it automatically connected, and I had to do a firmware update. In order to get the update to go through, there's a switch on the control board of the laser that had to be switched into the opposite position in order for the firmware to install. Once that was complete, I switched that switch back, and this laser was ready to move on and configure the Wi-Fi. Wi-Fi was very simple to configure using the Creative Space software. You just click on the configure button in the top right corner. From there, you can select Wi-Fi, and you'll be able to enter in your Wi-Fi information for whatever your home network is. Once you've entered in your network information, you can look back up here in the top right corner, and you'll see that it now says Wi-Fi. That means we are all set up and ready to start loading a file to cut on the laser. Taking a look at the xTool Creative Space, up at the top right, just a menu, some different tabs for changing some of the settings. This row of buttons on the left side are some different tools you can use for creating your artwork. Some of these grayed out buttons at the top will be activated depending on what tool you're working with or what you're doing with your artwork. Speaking of artwork, I'm going to just drag and drop mine right into this software, and you can see as I'm clicking and dragging the artwork around, some crosshairs pop up which help me out with aligning it. We'll just zoom in here so we can really see what we're working with. This is something that I'm going to make for my daughter, just a guitar pick shape with a horse head in the middle. This is going to be a set of earrings. You can see at the moment that each individual vector in here is a separate item. Now that may be related to the way I created this file, but to make this a little bit easier, I'm going to use some of the tools in the Creative Space software to group all of these together. I'm going to hold the Shift key and then start selecting each of the individual vectors. And then at the top menu, you can see that the Group button is highlighted. I can click that, and that will group all of those selected vectors together. I'll just spend a minute or so making sure I have each of these selected and group them all together so that all of the elements of the horse head are effectively one vector. Now I want to create a group from the lines that I want to cut. I intend to engrave the horse head and then cut out the shapes. Now we can set up each of these groups to perform the function that we need it to do at the machine. You can see when I select the horse head, over here on the right-hand side, it brings up a few different options. I'm going to select Engrave. There is a drop-down menu with some preset materials in there if you wanted to use one of those. For this project, though, I'm going to choose my own settings, but I do need to make sure that the horse head is set to Engrave. Now I'll choose the group of lines that I want to cut. Again, you could use the drop-down menu and select a preset material. I'm going to go ahead with a user-defined material and just choose my own settings. Now, since I want to make a pair of these earrings, this is super easy to do. I can just highlight this artwork, I'll right-click on it, and copy and paste in a second design. I can drag it around and align it wherever it needs to be. Once we have the artwork ready to go, now we can go down here in the bottom right corner and click the Process button. This brings up what they're calling the framing window. This screen gives you an opportunity to select the start point of the file. I'm going to leave mine in the upper left corner. Then you can click the Framing button. Now we're ready to frame our file. What that's going to do is basically trace an outline of the area that the machine is going to cut. This really helps us get the stock lined up. I I think it's kind of a neat feature. It's not one that I've ever seen before. I'm sure there's other machines out there on the market that do something like this, but it's one that I personally have never used. Before we actually frame the machine, I'm going to take this little aluminum sheet that's included in the box of parts. We'll just pull this protective coating off of there. This sheet's going to get placed under the cutting area. Really, its only purpose is to help protect the table or whatever surface you have the laser on. Now, if you've used other lasers, a lot of times there's a honeycomb type grid that your parts sit on, and that raises it up off of the table and helps protect the surface below. xTool does sell a honeycomb surface. It's an additional purchase, but it is available on their website. We're just going to use this aluminum piece. I'm sure it's going to work just fine. The stock that I'm going to be cutting for this project is just this piece of 1/8" thick birch plywood. Now I can just lay the stock in place somewhere in the cutting surface. Now the position is not 100% important. Just because I place the file in the center of the screen in the software, that does not necessarily mean that it's going to start cutting in the center. It's going to start cutting wherever the head is. So if we set it over here and hit the start button, it's going to start cutting in this area. It doesn't necessarily work, at least through the xTool software, on exact coordinates, as far as I know. So for alignment purposes, I'm just going to bring this kind of in here. We're going to line it up. You can see that there's a couple of crosshairs down here. Hopefully you can see that. That is offset just a little bit from the cutting head, but it is there to help you get things lined up. You can also change this to a laser spot. I might do that in the future, but for now, we're just kind of learning this thing, figuring it out. I'm going to go with those crosshairs, so we'll just set it up in the upper corner. Actually, before we do that, we need to focus the laser. That is done by flipping this little arm down. Then we loosen the thumb screw on the other side, slide this down until that arm comes in contact with the laser. Now this plywood has a little bit of a bow, so I want to put something on there. There, that ought to hold it down. I know we're going to be cutting in this area, so I'm not worried that the little hand plane is going to get in the way. Once we've tightened our thumb screw back up, we can flip this arm back up out of the way. Very important that you don't forget to focus the laser. And we can press the button. That's going to activate the framing, and we'll see roughly the cut area. You can see how it traces out the cut area. This is helpful if you need to align anything, move anything around. This gives you the opportunity to do it 2 times. So we just did it once. If we need to make any adjustments, frame it again, and we're ready to cut. Once you've verified that your stock is where you want it, you can click Framing Complete, and then in the upper right-hand corner, go ahead and click the Start button. This will send the actual laser file to the machine. Once you've sent the file to the laser, you have the option to save this as a separate file in case you ever want to use this exact file again. Now I can just connect the air assist, and we'll switch it on. And we're ready to cut. Before we hit that start button and make this cut, I want to mention something very important, and that is safety. Looking at a blue diode laser is almost the same thing as staring at somebody while they're welding without any face shield on. Now, I personally have burned my eyes many years ago by not taking proper precautions when welding. I don't want that to happen to you. It's not very comfortable, and who knows what the long-term effects are. Included with this laser is this pair of highly fashionable green safety glasses. Yeah, I know, it's kind of not very cool, but we're gonna wear them. Safety first. Now I know looking at this on the camera, you can't really tell how bright the light is, but trust me on this one, it is really bright. You definitely want to make sure you're either away from the machine or at least wearing the cool green safety glasses. If anybody has a recommendation for some cooler laser safety glasses, I'd love to hear what your suggestions are. We got nice clean cuts. Let's see how they turned out. They turned out pretty cool. I think I probably could have made the engrave a little bit faster. Got just a little bit of smoke staining on there. Not too bad. Most of the time, a little quick light sanding will remove most of that. I think those turned out really cool. It does leave some residue on this plate. You can probably use some alcohol or maybe some acetone or something and keep that nice and clean. I'm pretty happy with that. Well, I think we can call that first run a success with the xTool D1 Pro 20-watt laser. We got it all assembled, set up, and made a test cut, and got a cool Christmas project. Here's the earrings finished up. I sanded it a little bit, applied a couple coats of lacquer, added a little piece of hardware. These things are ready to be delivered, which by the time this video comes out will have already happened, but just a tiny idea of what you can do with a machine like this. So I guess the big question is, do I think this is going to work out for my needs in my shop? I absolutely think it will. Based on the results I'm seeing now, and we've barely scratched the surface of what this thing can do. There's tons of other projects that I have in mind that I want to try on this, little embellishments, that sort of thing. There's a ton of stuff that we're going to get into in the future. We also have a rotary to try out where we can engrave on the side of tumblers and that sort of thing. Let me know down in the comments if you'd like to see a line of Homebuilt Workshop tumblers. We might be able to make those, list them up on the website. Let me know if you're interested. So that concludes this video. Based on my results, I'm going to give it 2 thumbs up. Like I mentioned before, if you're interested in checking out one of these machines for your own shop, links in the video description. Hope this was helpful. Now I got to find a place to put this thing, and we'll see you guys next time. Thanks a lot for watching.